Hello again, and welcome to AI Educational Series Part 2. If you haven't watched Part 1, I would advise you to stop now and check the comments section and watch Part 1. So let's pick up where we left off last time, where we were training a data set consisting of these orange dots and blue dots and trying to find a simple machine learning model that would classify these two different training data sets. So with that said, let's run this model again and see what happens. So for a fairly basic classification problem like this, where the separation is quite clean, what you actually end up with is a simple linear regression based upon the two input features here. Unfortunately, what happens in real life is that you often encounter problems and data sets that are much more complicated and intermingle, like this one here where you see these two commingle spirals of both the orange and blue dots. So one of the things that I want to highlight is that machine learning is more of an art than any specific science, and specifically when you're developing machine learning models. So for example, if we were to run the prior model based upon just these two input features and one hidden layer with one neuron, this is what you get. So clearly the background here, this blue region, is not doing a great job, and hence the model is not doing a great job of classifying this data. So there's a few parameters you can play around with in machine learning. So for a nonlinear problem like this, it probably makes sense to add additional features like the square of the coordinates, the product of those two coordinates, and perhaps some sinusoidal components to capture the cyclicality of the geometry that you're seeing here in the input data. I don't believe that one neuron will probably suffice to learn this model. So what we can probably do is add in a few other neurons, say 7 for good measure. So let's see what happens when we run this model. Again, it's not doing a great job. What could be happening though is the learning rate we have here at 0.1 is probably too high, and it may be jumping around the optimal solution. So let's change it to a lower value, a slower learning rate, but with that smaller learning rate, what you get is a higher probability that you would converge to an optimum solution for this machine learning network. So let's see what happens. So nothing has changed much. So let's try adding another input layer here. Again with 7 neurons and see what happens. And yeah, it looks like it's doing a pretty good job. There's a few error here at the very end, but it seems like it's doing a much better job. To improve the model even more, and this is sort of the beauty that machine learning really encapsulates, and something that a lot of researchers are really trying to understand is what's happening in these hidden layers here, right? This is sort of the magic here. We don't know, quite frankly, why it's putting different weights on different neurons and how the neurons are propagating this and assigning different weights to the follow-on network within these hidden layers. So this is sort of the magic here, but that's sort of the power of machine learning, and something that this TensorFlow playground really allows you to see in a more intuitive manner than just a series of mathematical equations or watching a course on machine learning from Andrew Ng on Coursera, right? So let's see what happens here. We're doing actually a pretty good job here, but you're seeing some sort of instability at the very end, which could cause by this machine learning rate. So let's try to change around a few of the parameters here, perhaps introduce a different activation function, and maybe even slower learning rate and see what happens. And there you go. Looks like we hit a pretty good optimum here where all of the training data is being classified properly. And so I'll stop here and show you the output. So if you like this series, I'm going to be doing a set of other educational videos on AI and machine learning. So stay tuned. Follow Radna Intellectual Ventures, and I'll see you shortly. Thank you.